Morning world. Got a new project today. This is my scenic backyard, and we have a bit of a flooding problem when it rains. Now, it doesn't rain a whole lot here in Arizona, but when it does, usually during monsoon season, we get a lot of rain, and so this whole patio area gets flooded. So what are we going to do about that? Well, so this whole side yard used to be concrete, which was a real problem. I had someone come and remove this big section of concrete, and so that helps a little bit, but even when we get those heavy rains, it still can be an issue because this side will still flood, and we have the same issue on the other side. Alright, so in order to take care of the back side of the house, we're going to need to add a pipe to the outlet of this drain. And so what we're going to do is I'm going to rent a concrete saw again. I'm going to cut a channel in this bit of concrete, and then also the one way over there by the gate. It'll go out to the front yard. We'll continue our trench. We'll just dig. We'll go past this border through the lawn, and then we'll have one of those little pop-up emitters because I didn't want to deal with tunneling under the sidewalk and getting a permit to drain out to the street, though that would be an even better option. Alright, one thing that you have to have if you're draining water like this is you have to have a grade. So your pipe needs to be sloped downwards. Now, fortunately, the front yard is lower than the backyard. So all through here, it's pretty flat. So I'm going to have to start as high up as I can over where the drain is and have a very slight slope. But once we get past the gate here, we can have a much more aggressive slope. So as you can tell just from the driveway, we get a nice fall into the street, and so we'll start that more aggressive grade probably right after we pass this gate, and then we'll go down to the sidewalk and then that elbow, and that should give us a good fall to drain that water. Alright, let's talk materials. So at the end of the drain we'll have this elbow which will connect to that drain pipe, and then we have one of these pop-up emitters. I think it's important to have one of the ones with the springs. If you don't have a spring, if you're mowing your lawn, the way that the lawnmower works is it actually creates some slight suction upwards to pull the grass up straight. And if you don't have that spring, it'll pull this up and you'll just shred it, ruining it. So that's why the spring is important to help with that. So that'll go right there at the end. It should be, it'll be flush with the ground, so it should blend in fairly well. And then when it rains, the water will run down that grade, and then the hydrostatic pressure will push that emitter up, and it should drain out to the sidewalk. And because the sidewalk is sloped into the street, it'll go into the gutter and into the city sewage system.
Okay, it's time to do my favorite part of the project, which is going to be the math. So in order to figure out how much rain we need to remove from our yard, I found this helpful little formula here at the University of Arizona's website. So what they want us to do is calculate our square footage, multiply that by the rainfall in inches, and then multiply that by 6.623. So that will give us the number of gallons. So first, let's go ahead and grab the square footage. I went to this website where I can calculate the area. This is not my actual house. Just for safety reasons, I'm not showing where I live. But what you can do is you can type in your address, go to it there, and then we're going to draw an area. And based on the slope of your roof, you can define an area where you want to calculate rain will fall. So if we say all of the rainfall in this area is what we want to remove, we just draw our box there, and it gives us our area in square footage. So that's the first piece we need. All right, the next tool we need comes from NOAA. We're going to, you could type in your address here, or just, place the check wherever you live. and this will give you rainfall. And so what we're looking for is the 100-year rainfall, and we're going to use the 100-year rainfall. We'll just do it in 5 minutes because ultimately we want to get this down per minute because we're going to want to calculate gallons per minute. All right, here's the numbers that I came up with for my address. So I did rainfall for just a typical heavy rainfall that we get in an average year, and then also up to a 100-year rain. I took the area of both sides of my yard, and I just used the number, the larger number of the two. One of the two sides was smaller, so I just picked the larger number. And then I used rainfall for a heavy rainfall and then also a 100-year rain, and I got two different numbers. And I multiplied these three together to get my gallons per minute. So a typical heavy rainfall will give me around 36 gallons per minute to remove, and then in a 100-year rain, up to 122 gallons per minute. All right, now that we have our gallons per minute, we need to look at this table that I got from New Drainage Systems, and we're going to look at the corrugated pipe, and we need to know what our slope is in order to know how much rain we can remove. I measured out a 20-foot distance to have a drop of about 4 inches. The slope of my yard varies depending on where you're at. There are some areas where I have better drop than this and some areas where it's a little bit worse, but I think that this is a pretty good average, which gives me around a slope of around 1.67%. The way you get this is you just divide your drop by the distance that you've gone. So for a 3-inch pipe at 1% slope, I can remove 31 gallons per minute, and with 2% slope, I can remove 45. So I need somewhere in between those two for a typical heavy rainfall, and I'm at 1.67%. So I think a 3-inch pipe is probably the correct size for my application. I've decided not to design my system around the 100-year rain because, you know, technically if you did this 120 gallons with my slope, I mean, you need a 4-inch pipe isn't even necessarily going to flow it. I mean, it's going to do better than 3-inch. But I'm not really going to design this system around 100-year rainfall. But if you wanted a little bit more margin, you could go with a 4-inch. And then another thing to keep in mind is when I was, calculating my area and looking at my rainfall, I was being pretty conservative. I was looking at 100-year rainfall. I was using a little bit bigger of an area than I needed to, just because I wanted to stay conservative. So I do think the 3-inch pipe is going to be fine for me 99% of the time.
All right, there's a couple ways to deal with drainage. One of them is to take the water away, which is part of what we're doing. Another is to collect it and store it so that it can percolate slowly into the ground, which is what a drywall does. Also, certain types of drains, like say a French drain, can do that as well. Another way is to add landscaping. So plants can actually act like a reservoir because they're going to suck water up out of the ground. So besides just adding that pipe and that trench through here, which is going to help carry the water away, it's also going to help water percolate a little bit better. By adding some landscaping here, which I'll get around to, that's going to help to pull that water up when it rains, so that will reduce the need for it all to drain into the soil. Here in Arizona, we have this really hard clay-like soil. It doesn't drain very well. It does, but it just takes a really long time for it to percolate. And so we're going to be doing a few things to help speed that up so that we don't get that same flooding. So we'll cut from right around here, and I'm going to cut kind of diagonally so that it's a shorter distance for the pipe to go. And this is the saw we're using. It's just a regular concrete saw, gas powered. Plug in a hose right there. The water is going to help keep the blade cool, which is important to prevent the blade from burning out. We really don't want this thing overheating. It's going to help it cut better. So. Okay, we did half. We got one line down. The water's doing a pretty good job of keeping the dust down, but then it goes into all this slurry here, which is really slippery, so gotta be careful. Also, don't wear a 3-piece suit or anything, because you just wind up getting filthy from this. But it's going pretty smoothly. Just gotta kind of take it slow, do it in a couple passes, and it actually cuts through pretty well. Just kind of let the blade do the work if you're fighting it, or if there's too much vibration, you probably are doing something wrong. Gotta pick the blade up and set it back down. Alright, let's finish the last one, and then we can get it back to the store and start removing those big chunks. Okay, we finished with the concrete saw in the long portion. This section took me about an hour. So I cut 2 lines across, and then every 2 feet or so I cut a cross section that'll let me go back with a miniature breaker and then a big pry bar and take these pieces out one at a time. You can see that I didn't do it perfectly straight here because that's going to help with the drainage and just give it a nice aesthetic. Of course, I'm joking, it's crooked because I'm not very good. Man, I really hate digging. Okay. So, as you can see, we've got most of the drain in. I'm just waiting on the end cap to get delivered so that I can hook up the end of the pipe to the drain there. So put that in, finish getting this filled up. This is where the perforated pipe section starts, and it runs all the way to where the end of the rock is. And then the rest of the pipe is just solid pipe, so it's not perforated. Doesn't need to be wrapped. So I've got most of the drain in over here. Now I'm digging a little bit more because this is where I'll put that landscaping. So I'm getting the irrigation trenches dug here. And then we'll work on covering that up. There's extra dirt I'm going to use to grade this part of the yard so that there's a little bit of a contour to it. And then I'm going to put in this composite barrier in between the 2 sections. I'm doing that for a couple reasons. Because this side of the barrier is going to be raised a little bit, it's going to help prevent the soil from falling down into the this flat part, which I don't want. And then also for the plants that are growing here, it's going to help keep the moisture from the irrigation on that side of the barrier, and then prevent those roots from growing sideways into where our pipe is here, which again we don't want. So again, we want to encourage that moisture to go down so that the roots go down instead of across, because we don't want them infiltrating where we've got the pipe here. So we're hoping to get that in by the end of today, and then once we're done with that, we'll put down a barrier so that we prevent weeds from growing here. Let's take a look at the other side of the house. I've got part of the drain in already. So I got a couple of these Basin Collectors. I got one here, and I got one over here. Sometimes when I have to drain some of the water out of my pool, this will just be convenient. I'm going to add another little connector here so it drains right in. So if I ever need to partially drain my pool, this will help carry it out to the street. And I have part of the trench unfinished here so you can kind of see what's going on. So I dug my trench. It's graded in such a way that it provides a fairly even slope. And I've got the corrugated pipe, which is wrapped in a fabric, and then I also have that geotextile fabric as well. And so this fabric will line the trench, and then the pipe goes on top, and then we use this excess stone that I have from elsewhere in the yard. If you're buying it, you can use just like a crushed gravel or something, but this will work fine, and I had it on hand, so that's what I'm using. And then once that's all filled in, we've got good separation from the soil and the pipe with this fabric here that's lining the trench. And then this will all get filled over with pea gravel, and I'm probably going to put in some like 24-inch pavers that serve as like stepping stones to walk over here.
This is a cross section of what the drain is going to look like when it's fully installed. So here we'll dig out our trench, The pipe goes in it, and then that crushed gravel, or in my case, the extra gravel that I have left over. And then we have this geotextile fabric. That's what's keeping the soil from infiltrating all that stone. If you don't have something like this, eventually all the soil is just going to mix with your dry stone, and then you're going to lose all of your drain potential. So you need to make sure that you separate it somehow. I'm not completely wrapping this, so we're not going to call it a French drain because people will get mad at me. So we'll just call it a trench with a drain in it. And from some of the dirt that I'm excavating here, I'll put some of it on either side. On one side it would be the house, and on the other side it would be my fence. That way we get somewhat of a natural slope towards the center where that drain is. And so once the drain's in, we got our stone in there, it's separated. We'll also put a layer of rock on top, so it'll all look nice. You won't even be able to tell. One other thing to know about this drain is there are little holes in it, in the corrugated pipe, so that as water collects in this trench, it can actually enter this drain. So you think about, as rain comes down, it fills up this trench, it can flow into the pipe, and because the pipe is sloped, it's going to follow the slope of that pipe out to the street.
This is the fabric I bought, which will help separate the soil from that trench where I'm laying the pipe. It's a geotextile fabric. This stuff is specially made for this type of application. This was going to keep the dirt out of our pipe so that after it rains and all that soil gets loose, it's going to keep it segregated from the stone that we have in our trench. Alright, here's the pipe. This is just 3-inch corrugated pipe. It's wrapped in a sleeve, which is going to help keep that dirt out. For portions like here in the grass, I'll probably give it an extra lining with that geotextile fabric because I have enough, and that'll give me an extra layer of protection because I really don't want to be getting dirt in this pipe. This portion will not be a French drain, right? I'm not adding any stone. If you add a bunch of stone here and it's too shallow, if you don't have enough soil underneath the grass, your grass isn't going to grow very well, and I don't want that. So we're just putting the pipe down about 6 to 8 inches, depending on where it falls. Okay, so if you check out the level, it's about what we're going for. We want the bubble just past that line. That means that we're sloping down in that direction, and we just kind of move this all the way along, all the way to the end, and you can see we've got a fairly consistent slope here. All right, let's look at the output here. So where this elbow goes in, I dug it a little bit deeper, I added some more of that stone, and then it'll be wrapped in the fabric. And let's see if I can take this off here. So in the bottom of that elbow, there's a hole, and that's going to allow any water that stays in here to drain down into these rocks and eventually percolate into the soil. Because you have the pipe flowing down, but then you have this elbow, and so you'll have some amount of water in here that won't be able to make it out through the emitter, and so that's where it's going to go. It's going to drain through there. Where I hooked up the pipe, I put a little screw in there that'll hold where the pipe is connected onto here, because they don't really fit that snugly.
And with that, the pipe is in. It's ready to use. After the pipe was in, I covered it all up with rock, finished my landscaping, covered the landscaping area in some brown mulch, put a couple plants in, and here's the finished product.